Hello guys, my name is Balkrishna Shrivastava and welcome to CodeWithBK. So in this video, we write a Python program to find the HCF and LCM of two integers, and this question is also listed in the list of suggested practical Python programs for CBSE Board Class 11, Class 12 Computer Science students. So before we begin, it is a request to please subscribe to my channel, because out of 100 views, only 2 or 3 are subscribed. More than 95% of my audience is not subscribed, and the subscription is very important. So please do subscribe to my channel. And I also teach coding in Hindi on a separate Code with BK Hindi channel. So if you're better comfortable with Hindi, you can take a look at the channel there. And on that channel, I have solved all these problems already in Hindi, in Python. Okay, so please take a look and let me know your thoughts about it. Okay. Alright, so we have to find the HCF and LCM of two integers. So HCF we will find using two methods, and LCM we simply find using the formula. If you remember, we were taught a formula when we were very young, that HCF and LCM, okay, for any two integers a and b is equal to the product of those integers. Okay, so in order to find LCM, all I need to find HCF, and I can divide it by the, okay, for HCF we see the Euclidean method, okay, and then we see a recursive method. So this recursive method is also often referred to as Euclidean method as well, but the original Euclidean method was a little different from the recursive approach. All right, so what is Euclidean method? So this is the reference, and this, only this, if you read, you understand what a Euclidean method is. I will try to explain. Okay, so if you want to find, say, HCF of, say, 6 and 21, we know the HCF is 3, highest common factor. Okay, so the Euclidean method says that if you are given two integers a and b, positive integers a and b, of which you need to find the HCF, you have to keep replacing the larger value by the difference of the two as long as they don't become equal. Replacing the larger value, which is 21, by the difference of the two, okay, as long as they don't become equal. Okay, and when they become equal, this is the HCF. Okay, so you have to keep replacing the larger one by the difference of the two values. Okay, and the moment they become equal, it is the HCF, and this was the original Euclidean method. Okay, to find the HCF of two integers. So coding this, right, so I will go back to my code. I'll say using Euclidean method. Okay, so the idea is, as long as a is not equal to b, okay, and replace the larger one by the difference of the two. Okay, so if a is greater than b, okay, so a has to be replaced by the difference of the two, which is a minus b. So I can simply say a equal to a minus b, and b remains the same. Okay, in our case, if this was the case, right, this is a and this is b. Okay, if a is greater than b, b remains the same, and a becomes a minus b, so a becomes 3. Okay, now else will be the part where b is greater than a, because we are already taking the condition of equality. So this loop will run only as long as they are not equal. So if they are not equal, either a is greater than b or a is less than b. If b is greater than a, okay, replace b by the difference of the two. Okay, so b is equal to b minus a. Okay, and return a or b as the HCF. Return a. Okay, or you can return b as well. Okay, or b. Okay, either. You found your HCF. So for LCM, I'll simply use return a into b by HCF of a and b. Okay, product by the HCF. That's what we discussed for LCM. Okay, all right, so I'll take two integers a and b and print their HCF and LCM. So running this now, okay, this is the function for HCF I'm using. Python 3 HCF LCM. Say the examples were 6 and 21, 6 and 21. Okay, so HCF is 3 and LCM is 42, which is correct. It is coming out to be 42.0 because we are using this division. You can make this as integer division as well. Okay, 21, okay, 42. All right, and this will work for any set of any pair of positive integers. So if I have two prime numbers, say 7 and 13, so we replace the larger by the difference of the two. Okay, so 7, 6, then 7 minus 6 and 6, so which is 1 and 6. So okay, replacing the larger, and now replacing the larger. So 1, 6 minus 1, so 1 and 5, 1 and 5 minus 1, so 1 and 4, 1 and 4 minus 1, so 1 and 3, 1 and 3 minus 1, so 1 and 2, 1 and 2 minus 1, so 1 and 1. So finally their HCF is 1, because you know the HCF of two prime numbers is 1. So if I run for 7 and 13, I get my HCF as 1 and LCM is going to be their product. Okay, all right. The problem with this method is it does not works for only positive integers, does not work for negative integers. For example, if I have to find for HCF for minus 3 and 5, okay, so this HCF is going to be 1 into minus 3, 1 into 5, right? So if I do A and B, so you replace the larger one by the difference. So this is the larger one, replacing it by difference. This is going to be 8. Again, this is the larger one, replacing it by difference. It is going to be 11. So you see minus 3 is remaining the same, but this value is increasing by 3 in every iteration. So if I send minus 3 and 8, I will have an infinite loop. Okay, you see it keeps running. I have to stop this. Okay, because the positive value is going to keep increasing. Okay, following the algorithm for Euclidean. Okay, so when we approach this in a recursive way, okay, if I make this HCF 1, HCF 1 and HCF 1, I write HCF 2, which is going to be the recursive part. Okay, to find the HCF of two integers, okay, using recursion. Okay, this is the idea of Euclidean method. Okay, and works for negative integers. Okay, all right. So the algorithm is very standard, which is mentioned here. Okay, so this was the algorithm we discussed. Okay, this one. Okay, in this case we use mod instead of repetitive subtraction. What do I mean by that is we are replacing the larger value by the difference. So continuous subtraction is happening. Instead of that, okay, the way we are subtracting here. Okay, instead of that, what you can do is if you have 6 and 21, the same two integers, okay, replace the larger by the mod. Okay, so this is replaced by 21% 6. Okay, so now you have to find HCF of 6 and 9, which is what we are finding here. Then again 9 is replaced by 9% 6. This is 3. So 6 and 3, which is happening here. Now when 6 is replaced by 6% 3, okay, you get a 0. Okay, so 0 is an indication that you have found the HCF, which is the other value. Okay, and that is what we are doing here. If b equal to 0, return a. Okay, so writing this pseudo code, right? If b equal to 0, you return a. Okay, and otherwise return HCF 2. This is right. Return HCF 2 and b and a mod b. Okay, so calculating HCF 2 now and returning using HCF 2 now. Okay, should give us the same output. Okay, so our first case was 6 and 21. Okay, HCF and LCM. The other case was 7 and 13. Okay, this works for negative integers. For example, if I say minus 14 and 21. Okay, so HCF is 7, which is correct. Okay, highest common factor is correct. But if I have both the negative, then HCF is minus 7. It should be 7 because it's the highest common factor. Minus 7 is smaller than 7. Okay, 7 into minus 3 will give you minus 21. 7 into minus 2 will give you minus 14. So highest common factor is 7. So that is what it says in the algorithm. If negative inputs are allowed, if the mod function may return negative values, instruction return a must be replaced by max a of a, or basically absolute value of a. So either you return a or negative of a, whichever is the maximum, or basically return the absolute value. So you can say, instead of this, if negative values are allowed, okay, return max of a and minus a. So max is an inbuilt function, it will return the maximum. So now when I run this using minus 14 and minus 21, I get 7, which is correct. Okay, so this was the Python program to find the HCF and LCM of two integers. And the code that you should remember here is this one. This is a very standard solid code, runs very fast as well. Okay, and you can remember this for concept. So this was the original Euclidean method. So if you go back to the subtraction based version, which was the Euclidean's original version. So this is the Euclidean method, but it's often confused with this one because the inspiration for this method is derived obviously. Okay, so this was your Python program to find the HCF and LCM of two integers. Oh, I did not check for 15 and 27, my sample cases. One last, 15 and 27. HCF is 3 and LCM is 135. Okay, so this was the solution to this problem, and I hope this was helpful. So if you have any doubts, there's a part you don't understand, please let me know in the comments. I always try to answer all your comments, and you can also let me know in the comments if there's a question you want to solve or the concept you want to discuss. So please like this video, subscribe to my channel, and thank you for watching.